Hi all, welcome to another video of NS Pharma. In today's video, we are going to see GPAT 2020 question paper along with their answers and explanation. In the previous video, I already uploaded first 10 questions of the same question paper GPAT 2020. I will be putting this link on the description. You can check that also if you didn't watch that one. So we will move to the first question of this video. Question number 11. Following statement is more accurate with respect to limitations of Arrhenius relationship for the stability prediction. Following statement is more accurate with respect to limitations of Arrhenius relationship for stability predictions. Options are: same degradation mechanisms may predominate at different temperature. Order of degradation will alter at higher temperature. Equal moisture concentration will be mentioned at different temperatures. Option 4, less relative humidity and oxygen solubility at higher temperature. The question is, following statement is more accurate with respect to limitations of Arrhenius relationship for the stability prediction. The correct answer for this question is option 4, less relative humidity and oxygen solubility at higher temperature. Option 4 is the correct answer. We are moving to the next question. Question number 12. Stock is the CGS unit for the following property. Stock is the CGS unit of following property. Options are surface tension. Option 2, coefficient of viscosity. Option 3, kinematic viscosity. Option 4, fluidity. We know that Stock is a CGS unit of kinematic viscosity. Kinematic viscosity is the correct answer. Stock is represented by small letter C, then capital letter S, then T small, CST. That is the representation of Stock. It is the unit of kinematic viscosity. It is the 100th of stock. Centi means 100, 100th of stock. Okay. 1 centistock is 100th of 1 stock. So kinematic viscosity of water, this one also you just remember this one. Kinematic viscosity of water is 1.0038 centistock. 1.0038 centistock is the kinematic viscosity of water. Now we are moving to the question number 13. Riboflavin chemically is. Riboflavin, we know that is a vitamin B2. Vitamin B2 is the riboflavin. So what is the chemical name of riboflavin? Options are 6,7-diethyl isoalloxacin. Option 2, 6,7-dimethyl isoalloxacin. Option 3, 8,9-dimethyl isoalloxacin. Option 4, 8,9-diethyl isoalloxacin. Riboflavin. For that we should know the structure of the riboflavin. I will write it on here. Just one benzene ring here, then here, come on, and another. Here it is N, here it is ketone group, then NH, then ketone group, then a double bond. That's it. Here it's the connection comes CH2, then OH, H, then OH, H, then OH, H, then CH2, OH. This is the one more thing, CH3, here one CH3, here one CH3. This is the structure of riboflavin. Riboflavin structure is this one. So we know that here 2-dimethyl is there, methyl group is present. So the option 1 is not correct, option 4 is also not correct, or maybe 2 or 3. So for that one we should know the numbering of the structure. For 1, 2, 3, 4, then 5 is not here, not 5, this one, this nitrogen is numbered as 5, this is the fifth one, then 6th, 7, 8, 9, 10. This is the numbering. Okay, 1, 2, 3, 4, 5 here, 6, 7, 8, 9, 10. So the branch is present in 9th. Here methyl groups are present in 6th and 7th group, 6th and 7th position. So the correct answer is option 2. Option 2 is the correct answer. Okay, 6,7-dimethyl isoalloxacin is the riboflavin. This is the structure of riboflavin. Now we are moving to the next question, question number 14. The unequal attractive forces acting on the molecules at the surface of liquid gas interface when compared with the molecular forces in the bulk of the liquid is due to. The unequal attractive forces acting on the molecules at the surface of liquid gas interface when compared with the molecular forces in the bulk of the liquid is due to. Options are less adhesive force of attraction, option 2 absence of adhesive force of attraction, option 3 less cohesive force of attraction, option 4 absence of cohesive forces of attraction. The correct answer is because of due to less adhesive force of attraction. That is the correct answer. Now we are moving to the question number 15. The complexation of quinine with hexyl salicylate. Complexation of quinine with hexyl salicylate is an example of absorption by. Options are ion pair transport, option 2 facilitated diffusion, option 3 penocytosis, option 4 convective transport. Here it is, question is quinine complexation with hexyl sulfate salicylate is an example for absorption by. The correct answer for this question is ion pair transport. In this ion pair transport, we know that strong electrolyte drugs are highly ionized. They are the charged molecule. They are charged molecules. So this strong electrolyte drug always they maintain their charge at all the pH values and they cannot penetrate the membrane rapidly. So the penetration power is very poor. So when this ionized drug is linked with an opposite charged ion, means one ionized drug is linked with or complexed with another oppositely charged ion, then that is called ion pair. Which is overall the charge is neutral. The overall charge of that pair is neutral because one charge is there, then opposite charge is also there. So the total charge become neutral. This neutral drug complex can easily diffuse across the membrane. That is the mechanism of ion pair transport. Example for this technique is, example for ion pair transport absorption is, one is quinine with hexyl salicylate. Another example is propranolol. Propranolol with oleic acid. This is another example for this same ion pair transport mechanism. Now we will move to the next question, question number 16. When a solid forms a gel more readily when gently shaken or otherwise sheared than when allowed to form the gel while the material is kept at rest. The phenomenon is known as. I will read the question once more. When a solid forms a gel more readily when gently shaken or otherwise sheared than when allowed to form the gel while the material is kept at rest. The phenomenon is known as. Options are antithixotropy, option 2 rheopexy, option 3 thixotropy, option 4 negative rheopexy. The correct answer for this question is rheopexy. So what is rheopexy? It's actually a rare property of non-Newtonian fluid. It's a rare property of non-Newtonian fluid. non-Newtonian fluid. They are rare property of non-Newtonian fluid. They show time dependent increasing the viscosity. The viscosity will increase on time. So the longer the fluid undergoes shearing forces, the higher its viscosity. The fluid undergoes shearing. The longer the fluid undergoes the shearing force, the higher its viscosity. That is known as rheopexy. So when we are writing, when we are making a graph, we know that this is the Newtonian fluid. When there is no like this, no change. But in case of rheopexy, this is viscosity. In the y-axis, it is viscosity. In the x-axis, this is time. In the x-axis, it is time. So as per the Newtonian fluid, when the time is going, there is no change in the viscosity. That is the Newtonian fluid. Another one, this is a rheopexy. When the time is going, the viscosity is also increased. That is rheopexy. That is solid will become solid forms a gel more readily when gently shaken or otherwise sheared than when allowed to form gel when the material is kept at rest. Another one is thixotropy. Now this is rheopexy. In case of thixotropy, this is shear thinning. That is, it will decrease the viscosity. When the time is going, the viscosity will be decreased. That is thixotropy. Okay, these are the main important point regarding this one. Now we are moving to the 17th question. Human serum albumin has a molecular weight of. Options are 44,000, then option 2 34,000, option 3 65,000, then option 4 59,000. Human serum albumin is actually serum albumin found in the human blood. It is the most abundant protein in the human blood plasma. So it is the most abundant plasma protein, albumin, and it is produced in the liver. The correct answer for this question, that is albumin molecular weight, is 65,000. Option 3 is the correct answer. 65,000 is the molecular weight of human serum albumin. Albumin is produced from liver. We are moving to the next question. Question number 18. Drug products that contain the same therapeutic moiety but as different salt, esters or complexes are called as. Drug products that contain the same therapeutic moiety but as different salt or esters or complexes are called. Options are pharmaceutical alternative, therapeutic equivalents, then therapeutic alternative, pharmaceutical equivalents. The correct answer for this question is pharmaceutical alternative. Pharmaceutical alternatives. So what is a therapeutic equivalent? Pharmaceutical alternative, this one in the question itself is there. So what is therapeutic equivalence? Therapeutic equivalence are actually two medicines that have same clinical effect. Thus two medicines that have the same clinical effect and safety profile are said to have therapeutic equivalent. They are therapeutic equivalent. Two medicines, they have same clinical effect and safety profile. They have same safety profile also. Then it is called same clinical effect and safety profile. Then it is called therapeutic equivalence. Another one is therapeutic alternative. Therapeutic alternatives are, they are the drugs that may have chemically different content. Maybe they are chemically different. We are talking about therapeutic alternative. They are chemically different content, but they have the same purpose. They have the same effect as for the treating a condition. Okay, they are chemically different, but they have the same purpose of the other drug as for the treating a special condition. That is the therapeutic alternative. Then pharmaceutical equivalents. They are drug products in identical dosage form and routes of administration that contain identical amount of the identical active drug ingredient. That is same salt. It should be same salt. It should be same ester, or it should be same complex. Here the question it was different, but here in the pharmaceutical equivalent it should be same. Their drugs, their products, they are identical in dosage form, they are identical in route of the administration, and also they contain identical amounts of the active ingredient, and they have same salt, same ester, same complex. That is the pharmaceutical equivalent. Now we are moving to the question number 19. Following amino acid does not exhibit optical isomerism. Following amino acid does not exhibit optical isomerism. Options are alanine, leucine, glycine, serine. The correct answer is glycine. Option 3 is the correct answer. So glycine is the simplest amino acid. We know that simplest amino acid is glycine, and is the only amino acid that is not optically active. It is only one amino acid which is not optically active. Glycine structure, that is, we know that amino acid actually NH2, then CH2, then acidic group COOH. One amine group, one acidic group, acid group, carboxyl group, then one carbon. That's it. NH2, CH2, COOH. That is the glycine. Question number 20. Molar heat capacity of a system is defined as. Molar heat capacity of a system is defined as. Options are the amount of heat required to rise the temperature of 1 mole of the system by 1 Kelvin. Okay. Option 2, the amount of the heat required to decrease, here it is rise, to decrease temperature of 1 mole of the system by 1 Fahrenheit. Option 3, the amount of heat required to rise the temperature of 1 mole of the system by 1 Fahrenheit. The amount of heat required to decrease the temperature of 1 mole of the system by 1 Kelvin. The correct answer, molar heat capacity, the definition is option 1 is the correct answer. That is the amount of heat required to rise temperature of 1 mole of the system by 1 Kelvin. 1 Kelvin, it is used to rise the temperature. Okay. Now we are moving to the question number 21. The polymorphs. The polymorphs exhibit the following different properties except. The polymorphs exhibit the following different properties except. Options are X-ray crystal and diffraction patterns, solubilities, chemical structure, melting points. We know that polymorphs are the crystalline material that have the same chemical composition. They have the same chemical composition but different molecular packing. Examples of polymorphs of carbons are diamond, graphite. All are examples for that one. They are totally composed of carbon, but their physical and chemical property vary drastically. Polymorphs have significant difference in their physical property. They are different in physical properties. Examples: solubility. They are different solubility, melting point, then particle size, dissolution rate, hygroscopy. All these they are different. So here the correct answer, they are different properties but except chemical structure. Question number 21, option 3 is the correct answer. They are not different in chemical structure. They have same chemical identity. Question number 22, method of study drug distribution pattern is. Method of study of drug distribution pattern is. Options are mass spectroscopy. Option 2, nuclear magnetic resonance, NMR. Option 3, that is UV visible spectrophotometry, then fluorimetry. The correct answer for this question is option 1, mass spectrophotometry. That is the It's used for study of drug distribution pattern. NMR spectroscopy is used. NMR spectroscopy is used for determining the content and purity of a sample, as well as its molecular structure. This is the NMR spectroscopy technique is used for this purpose, for the content, and also it is used for the purity of the analyte, means purity of the content, purity of the sample given, and also the molecular structure of the sample. For this purpose, NMR spectroscopy is used. Now we are moving to the question number 23. In the process of extraction, ethanol is used as a solvent for. In the process of extraction, ethanol is used for the extraction of. The options are waxes, gums, alkaloids, sucrose. The correct answer is alkaloid extraction. Ethanol is extraction of alkaloids. In the process of extraction of alkaloids, ethanol is used as a solvent. In case of waxes, here option waxes, the solvents used are ethyl and butyl acetate. Ethyl and butyl acetate. Ethyl and butyl acetate for the waxes. As per the gum, acetone, then ethanol and methanol, they also can be used. Ethanol and methanol. All this. As for the sucrose, it is water. Water is used for the sucrose. Acetone is a good solvent because it has ability to dissolve both polar and non-polar substance. Acetone has got ability to dissolve both polar and non-polar substance. It can dissolve both polar and non-polar substance. Now question number 24. Question number 24. The dispersion of coarse material by shearing in a narrow gap between static cone and rapidly rotating cone is caused by. Options are colloid mills, peptidization, ultrasonic irradiation, electrical dispersion. I will read the question once more. The dispersion of coarse materials by shearing in a narrow gap between static cone and a rapidly rotating cone is caused by. The correct answer is colloid mill. 24. Option 1 is the correct answer. In colloid mill, how is this structure? Here it is hopper. In this, feed is given, that is coarse materials. Feed is given. Through that it will go, and here it is. Okay, this is a rough picture of the this is the rotator. This is the rotator. Okay, rotator. Now we will here it's like that. This is a starter. Okay, this one is starter. So the question was narrow gap between static cone. This is a static cone, then and a rapidly rotating cone. That is rotator. That is connected with motor. This is rapidly rotating. Normally in the almost 13,000 feet per minute. Okay. Then the feed will come through this one, and it will go through this narrow portion. At that time, this coarse material will grind it up, and it will it will be produced. This one fine particle will be produced. So this is the colloid mill mechanism. This is the starter. This is the rotator. Feed is given through this one. So next option of peptidization. Peptidization is also known as deflocculation. Deflocculation. It is also known as deflocculation. It is actually the process of responsible for the formation of converting precipitate into colloid. It is the process of conversion of precipitate into colloid by shaking with it electrolyte. In the peptidization, they will convert the precipitate into the colloid form by shaking with an electrolyte. That is the peptidization or deflocculation. Next one is ultrasonic irradiation. In this case, ultrasonic waves are passed. This is a new technique, new technology. Ultrasonic waves are passed through the liquid medium, and when it is passed through this liquid medium, ultrasonic waves, large number of bubbles are formed, micro bubbles are formed. They will grow and they will collapse in very short time, and that is called ultrasonic cavitation or ultrasonic irradiation technique. That is that one. Now we will move to the next question, question number 25. While studying solid state physicochemical properties, the packing property of a drug include. While studying solid state physicochemical properties, the packing property of the drug include. Options are entropy, heat capacity, solubility, refractive index. The correct answer is refractive index. Refractive index is coming under packing property of the solid state. Now, actually, what is refractive index? It is the measure of how much light slows down when it is going to the goes into the new medium. That's a measure of how much light is slowed down when it is goes into the new medium. So it is represented by N, and for the vacuum it is N of vacuum, it is 1. So for finding out the refractive index of a medium, N of a medium, that is refractive index of medium, is equal to C divided by V, that is speed of light in vacuum. Speed of light in vacuum divided by speed of light in medium. That is the C by V is the formula for finding out refractive index.